Okay, so imagine this for a moment. You step onto another world expecting silence, dust, and empty rocks, but instead you find materials that behave like they're alive, particles that ignore physics, and signals from space that don't seem to follow the rules of our universe. Space looks calm from far away, but the closer scientists examine it, the more it begins to feel unpredictable, almost rebellious. Because scattered across our solar system and beyond are discoveries that don't quite fit our understanding of physics. Strange materials, impossible signals, particles that behave like they belong somewhere else. These aren't science fiction stories, they're real scientific observations that still puzzle researchers today. Number 10. The lunar dust that almost behaves alive. When the Apollo astronauts first stepped onto the moon, they expected rocks, silence, and fine gray soil. What they didn't expect was dust that acted like it had a personality. Lunar dust turned out to be far more aggressive than anyone imagined. The powdery particles clung stubbornly to everything: boots, gloves, equipment, even the inside of the lunar module. Brushing it away barely worked. It stuck like glue. The particles scratched visors, jammed mechanical parts, and even irritated the astronauts' lungs when tiny amounts were inhaled. Neil Armstrong described the smell of the dust inside the module as something like burnt gunpowder, a strange detail considering that nothing can burn on the moon without oxygen. But the real mystery appeared when scientists studied the samples back on Earth. As soon as lunar dust came into contact with Earth's air and humidity, the particles began reacting in unusual ways. Some fizzed, some fused together, and others produced tiny electrical effects. Researchers eventually discovered that solar radiation had charged the dust for billions of years. Each grain carried a static electric charge, almost like a microscopic battery. Even so, the material behaved strangely. The grains contain razor-sharp glass fragments formed by constant micrometeorite impacts. These fragments cling together in odd clumps and sometimes move across surfaces in ways that seem almost deliberate. Scientists don't actually believe the dust is alive, of course, but its unusual electrochemical structure makes it behave very differently from any soil on Earth. Sometimes it feels less like dirt and more like alien material that evolved under completely different physical conditions. Number 9. The helium-3 that shouldn't be so common. Among the most valuable things the Apollo missions brought back from the moon wasn't a rock you could hold. It was an invisible isotope, helium-3. On Earth, helium-3 is incredibly rare, but on the moon, scientists found it scattered across the surface in surprising amounts. This isotope is fascinating because it could one day power nuclear fusion reactors, producing enormous amounts of clean energy without radioactive waste. But the strange part wasn't simply its presence, it was how evenly it appeared across the lunar soil. Helium-3 forms when solar wind particles embed themselves into the surface of airless bodies, like the moon. Scientists expected random concentrations depending on exposure to sunlight. Instead, they discovered something much smoother. The isotope appeared spread across the lunar surface in a strangely uniform layer, almost as if the process distributing it had been incredibly consistent. Even the isotopic signatures sometimes differed slightly from what solar models predicted. Some researchers suggested unknown solar events could have altered their particles. Others wondered whether the moon once had environmental conditions that spread them more evenly. Whatever the explanation, the moon seems to produce and store helium-3 far more efficiently than Earth ever could. In a sense, the lunar surface behaves like a natural reactor, quietly collecting fuel from the sun. Number 8. The Martian meteorites that confuse time. Meteorites blasted from Mars have been landing on Earth for millions of years. When scientists began studying them closely, they expected to learn about the red planet's geology. Instead, they found something deeply puzzling. Radioactive dating methods showed conflicting ages inside the same rocks. Some parts of a meteorite suggested they were billions of years old, while other portions appeared much younger, as if their atomic clocks had somehow been reset. Normally, that shouldn't happen. Radioactive decay follows extremely predictable patterns. It's one of the most reliable tools scientists have. Yet these Martian samples seemed to show signs that their isotopes had been altered after forming. Some researchers think intense cosmic radiation could have rearranged their atomic structures during long journeys through space. Others suspect Mars once experienced powerful magnetic or geological events capable of altering minerals at the atomic level. Whatever the cause, the rocks tell a complicated story, one where time, radiation, and planetary history interact in ways we still don't fully understand. Number 7. The mysterious metal linked to asteroid Psyche. Certain meteorites discovered on Earth appear to originate from the metallic asteroid 16 Psyche. When scientists analyzed fragments believed to come from similar objects, they found alloys that seemed almost too perfect. The metal contained precise mixtures of nickel and iron, arranged in extremely ordered crystalline patterns. These structures usually form very slowly inside the cores of large planetary bodies. But some samples appeared unusually symmetrical, far more uniform than expected from chaotic natural formation. Even more interesting were their magnetic behaviors. Certain fragments responded to magnetic fields in inconsistent ways, sometimes attracting and sometimes repelling, depending on subtle changes in orientation. The asteroid Psyche itself is thought to be the exposed metallic core of an ancient protoplanet that lost its outer layers in violent collisions billions of years ago. If that's true, it may represent one of the first chances humanity has to directly study the inner structure of a planetary core, and what we learn there could reshape our understanding of how planets form. Number 6. Interstellar dust that challenges thermodynamics. In 2006, NASA's Stardust mission returned tiny grains of dust captured from deep space. These particles had traveled between stars for billions of years before being collected by the spacecraft. Under powerful microscopes, scientists expected to find simple minerals formed inside distant stars. Instead, they found structures that seemed strangely contradictory. Some grains appeared to contain minerals that normally form at extremely high temperatures, alongside materials that require very cold conditions. Finding them together was puzzling. It suggested the particles had experienced complex journeys through violent stellar environments before drifting into interstellar space. The isotopic patterns inside some grains also didn't match typical stellar signatures, hinting they may have formed in rare or unusual astrophysical events. These microscopic travelers forced scientists to rethink how matter moves and evolves between stars. Sometimes the smallest particles carry the biggest mysteries. Number 5. The mysterious signals near the edge of the solar system. When Voyager 1 crossed the boundary of our solar system into interstellar space, its instruments began detecting subtle changes in the environment around it. One of the most intriguing discoveries was a low-frequency vibration in the surrounding plasma, a faint hum created by waves moving through the thin gas between stars. Scientists believe these signals come from disturbances caused by distant stellar explosions. But as Voyager travels farther away, the environment continues to reveal new details about the structure of interstellar space. Magnetic fields behave differently there. Cosmic particles move through regions shaped by the interaction between the solar wind and the surrounding galaxy. In many ways, Voyager is now exploring territory humanity has never measured before, and every signal it sends back helps scientists map the invisible boundary between our solar system and the vast ocean beyond.
Number 4. Microbes that survived the vacuum of space. Experiments on the exterior of the International Space Station have revealed something remarkable about life. Certain microorganisms, especially hardy bacteria and spores, can survive the extreme conditions of outer space for surprisingly long periods. The outside of the station exposes them to vacuum, intense radiation, and extreme temperature swings. Yet, some microbial samples placed there during experiments have endured for months or even years. When scientists study them afterward, they often discover new mutations and unusual adaptations. Most researchers believe these organisms originally came from Earth, carried accidentally by spacecraft or astronauts. But their survival demonstrates something important. Life can be far tougher than we once believed. And if microbes can endure the vacuum of space for extended periods, it raises fascinating questions about how life might travel between planets.
Number 3. Titan's methane seas and unusual chemistry. Saturn's moon Titan is one of the most Earth-like worlds in the solar system, and also one of the strangest. Instead of water oceans, Titan has vast lakes and seas made of liquid methane and ethane. At Titan's freezing temperatures, these normally gaseous hydrocarbons behave like liquids. Rivers flow, clouds form, rain falls. But there's a problem. Methane should break down in Titan's atmosphere over time due to sunlight, yet measurements show that the gas continues to exist in large amounts. Something must be replenishing it. Scientists suspect underground reservoirs or chemical processes deep below the surface might be releasing methane into the atmosphere. But Titan's chemistry remains mysterious. Some researchers have even speculated about exotic forms of life that might use methane instead of water as a solvent. While no evidence of life has been found, Titan remains one of the most intriguing environments for studying alternative chemistry in the solar system. Number 2. Particles that appeared to pass through Earth. High-altitude experiments above Antarctica have detected extremely energetic particles produced from distant cosmic events. In a few cases, detectors recorded signals that seemed to originate from particles traveling upward through the Earth. That initially confused scientists because most high-energy cosmic particles should be absorbed by the planet before emerging on the other side. After careful analysis, researchers concluded that the signals likely involved rare types of particles called neutrinos, which can pass through matter almost effortlessly. Trillions of neutrinos pass through your body every second without interacting with anything. Occasionally, however, they collide with atoms and create detectable signals. These unusual events highlight just how strange the subatomic universe can be. Particles so ghost-like that entire planets barely slow them down. Number 1. The mysterious motion of deep space probes. In the 1990s, scientists noticed something odd while tracking spacecraft like Pioneer 10 and Pioneer 11. Their trajectories showed a tiny but consistent deviation from predicted motion. The spacecraft appeared to be slowing down slightly more than expected. At first, researchers suspected unknown forces or even new physics. But after years of investigation, they discovered a surprisingly simple explanation. Heat emitted from the spacecraft's onboard systems was being radiated unevenly into space, producing a faint but measurable push, like a microscopic thruster. Even such a tiny effect was enough to influence the spacecraft over billions of kilometers. The discovery served as a reminder that space exploration pushes our measurements to extraordinary precision, and sometimes solving a cosmic mystery requires understanding the smallest details. Space is often portrayed as empty and quiet, but the truth is far more interesting. Every mission we launch, every sample we collect, and every signal we receive reveals new puzzles hiding in the universe. Some will eventually be solved. Others may lead to entirely new fields of science. Because the deeper we explore the cosmos, the more we realize how much remains unknown. And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.